So this is the video for 1.4 solving literal equations. This was our day of application. We've been working on this for 2 or 3 days now, so hopefully you're getting a little more comfortable working with the formulas, and that's kind of what we're going to talk about today. So this is actually an excerpt from your notes today. Here we have a word problem. It says that you own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet. To pay for a new water system, you are assessed a $5.50 per foot of lot frontage. So the first thing that I would do if I were you is I would go ahead and draw a picture, and that's how I told you guys to start today in class. So we know we have a rectangular lot. So I've drawn a rectangle here. It's not exactly the best rectangle, but it'll work. And I'm going to label it with the information that they gave me. So the only thing that they told me is that the area of the entire lot was 100,000 square feet. And then they also told me that it is 500 feet deep. So if you think about this like a lot, you know that there's a front and a back, and then deep would be your width. So we know that this is 500 feet. We want to know about the lot frontage. So we're actually trying to find this portion. Okay? So that's going to be our x. So we're given some information here. We know the area, and hopefully you guys know that to find area of a rectangle, you're going to do your length times your width. So we are calling our width 500 feet, and we are calling our area 100,000 square feet. So I'm going to go ahead and substitute those values into my formula. So if I already know the area, and I'm looking for x, but I know that I have 500, I'm looking at a one-step equation here. So notice this is answering the question to find the frontage of your lot. Okay? So from here, the opposite of multiplying by 500 would be to divide by 500. So I'm going to do that on both sides. And that tells me that the frontage of my lot should be 200 feet. That's x. Okay, so if you look at your picture, in reality, the frontage of your lot is actually more narrow than how deep it is, but you get the idea here. So we've answered part A. We know that part A is that it's 200 feet of frontage. And now we're going to go ahead and look at part B. So part B says, how much would you be assessed for the new water system then? Well, if you read this last part of the sentence, it says to pay for that new water system, they charge you $5.50 per foot of frontage. So I just need to use that information and the information that I found to find my new amount. So we know that there are 200 feet of frontage, and they're going to charge me $5.50 per foot. So if I just multiply here, I find out that my new water system is going to cost me $1,100. Okay, so this is kind of easing you guys into some word problems and using equations to solve them. Okay. After we completed that first problem in class, what we did is we looked at this chart. So this is actually on your notes if you need to refer to it at any time during your homework or anything else. And these are some common formulas that you guys are going to be working with this year. So we know that we can find temperature in degrees Fahrenheit or in degrees Celsius. And so they gave us the formula for Celsius, which was C equals 5/9 times F minus 32. They gave us the simple interest formula, which remember that is I equals PRT, where I is your interest, P is your principal, R was your rate, and T was your time in years. And then we also looked at the distance formula, which is D equals R times T, or distance equals rate times time. So number 9 on your notes talks about that temperature formula. So they're telling us that a fever is generally considered to be a body temperature that's more than 100 degrees Fahrenheit. And they've given us a temperature in Celsius. They told us your friend has a 37 degree Celsius temperature, and they want to know, is that considered a fever? So looking at this formula right here, what I'm actually trying to do is solve for F. So I'm going to sub in the 37 degrees Celsius in for C, and I am going to check and see if my answer is actually a fever. So I'm going to do that here. So I know that C was equal to 37, and I'm just using the formula here from my chart. So I know that that's 5/9 times F minus 32. Okay, so from here, there's a couple of ways that we could go about this to start. I would suggest going ahead and clearing out that fraction, which you guys know that we're dividing both sides of this equation by 5/9, which, remember, when you divide fractions, what you're really doing is multiplying by the reciprocal. So 5/9 over 5/9 will cancel, and then 37 divided by 5/9 is actually equal to 66.6. Now remember, if you're using a graphing calculator, we talked about in class today that it will take fractions. You just have to remember to put those fractions in parentheses. And also to get the division bar, remember a fraction bar is just division, so you're using divided by sign. Okay, so from here, we now have 66.6 equals F minus 32, because I did 37 divided by 5/9. So the opposite of subtracting 32 would be to add 32 to both sides. So I'm going to add 32 to both sides, which will cancel on this side, and that will give me my temperature in Fahrenheit. So I'm adding 66.6 plus 32 to get 98.6. Okay, so we have a numerical answer here. We know that F is equal to 98.6. However, it's really important that you go back to the problem and make sure you're answering the question. So the question was, does your friend have a fever? The question was not, what is the temperature in degrees Fahrenheit? So it tells me that a fever has to be greater than 100 degrees, and 98.6 is not bigger than 100. So to answer this question, I would actually say no, because he doesn't have a fever. His temperature is actually normal. Okay? So let's look at this second problem. So this second problem is talking about a truck driver averaging 60 miles per hour while they're delivering freight and 45 miles per hour on the return trip. They gave us our total driving time as 7 hours, and they're asking us how long each trip took. Okay, so on this problem, we're actually going to have to manipulate the formula before we start plugging things in. So we know that distance equals rate times time. So distance equals rate times time. The only thing they gave us here is we know our rate and we know our time, total time. So I'm going to actually solve this for t so that I can get the time by itself. So the opposite of multiplying by the rate would be to divide. So I know that t has to be equal to the distance divided by the rate. And that's going to allow me to use the information that they gave me in the problem. So I know that one of the trips, they traveled at a rate of 60 miles per hour, and I'm not sure how far they went. So I know that d over 60 would be equal to the total time, which we're not sure how long it took just for the delivery part. So I need to add that to d over the other rate, which was 45 miles per hour. If I add the distance over 60 plus the distance over 45, I know that the total trip took 7 hours. Now, this is actually, several steps that we're having to do. We're having to use what we had to figure out the distance traveled. So that's what I'm going to do first. So I know that d over 60 plus d over 45 has to equal 7. Now, in order to add fractions, you have to have a common denominator. So that's the first thing I'm going to do. I know that the common denominator between 60 and 45 would be 180. So I'm going to rewrite these fractions with a common denominator. So in order to make these something over 180, I know that I have to do the same to the top and the bottom of the fraction. So 60 times 3 is 180. So I have to multiply d times 3 as well. So I have 3d over 180 for my first fraction. Now I'm looking at my second one. I know that 45 times 4 is 180. So I have to multiply the numerator by 4 also. So that's where I'm getting 4d. And that's going to equal 7 still. Now I can actually add those fractions together and get that 7d over 180 equals 7. Now to solve this, for d, I'm going to multiply by 180 because that's the opposite of dividing, and whatever I do to one side, I'm going to do to the other. And that's going to give me that 7d is equal to 1,260. Then the opposite of multiplying by 7 is to divide by 7, so I'm going to divide both sides by 7. And when I do that, I find out that the distance traveled is actually 180 miles. Okay, so how is that going to help me answer this question? The question was not how far did they travel, the question was how long does each trip take? Well, if you go back to your original equation that you solved, you know that time is equal to distance divided by rate. Well, now we have our distance. So if I know they traveled 180 miles both ways, I can just plug that in to the equation that I wrote. So I know that distance, being 180, divided by 60 will tell me how long the first trip took, the trip to actually get there. So 180 divided by 60 is 3. So I know that my first trip took 3 hours. And if the total time was 7 hours, then that tells me that my second trip had to take 4 hours because 3 plus 4 is 7. Okay? So that was a long one. That had a lot of work in it. So if you don't understand this, we actually did 2 problems like this, but if this is still giving you a little bit of trouble, you can always come in for tutoring, and I will see you guys tomorrow in class. Have a great day.